all of you to note it down. In db.h, if you remember, we ran into a compilation error yesterday because one of the functions required a pointer variable, but we were not passing anything. Okay, so we made a change in db.h, not db.h. Just one second. I think in syntab maybe. No. Okay. No. This one. Let's see. Okay. We had made a change somewhere. I'm not able to recall. Okay. Can one of you start the recording, please? And let me know if it has started.
Sir, it's already recorded.
Is it? Yeah. I think it's kind of automatic, no? Didn't know that. Okay. So we had made some changes. I don't know what happened to the code. Okay, no worries. So let us go to Lexer.c. So we had where was that function? I'm not able to remember it. Yeah, we had done this right yesterday. Forward pointer. So this should be in double buffer. So let us go to db.h. Yeah, so this is the change we did yesterday, but I had done this in db.c. Okay, so obviously that will not work because, see, when you include a header file, okay, only those variables, macro definitions, and function declarations are accessible to the other file, which is including a particular header file. Only those things which are in the header file will be accessible, right? So if you just look at db.c, we have this in forward and in lex pointer and all these here. Okay, so just having a forward pointer here, forward variable, whatever, here in db.c is not really going to help us because we need this forward pointer to be in the header file. Okay, so please make a note of this change here. Just put an extern here. Okay, in db.h, this is db.h, and just add this single line, extern int forward. Okay, is this clear, everyone? Just one line you need to add in db.h. So now let us quickly check if things are working okay or not. cc minus c, db.c. Okay, no errors. cc minus c, syntab.c, no errors. cc minus c, lexer.c. Okay, perfect. So all that is required now is to write a program that would be using all these three programs, isn't it? So let us go for parser.c. Okay. So this is a toy parser. Please keep this in mind. By toy parser, what I mean is, uh, see, when we talk about a parser or the syntax analyzer, where we check the syntax, we need to have a few grammar. Okay, we need to have a few productions that would be representing the language that we are working on. Okay, so if an input doesn't fit into a given grammar for a given language for which you are developing a syntax analyzer, then you say there is a syntax error. So the bare minimum thing that we need for implementing a parser is a production. Okay, some productions. Basically, we need a grammar. But here, why I'm saying it's a toy parser program is because this is simply a driver program which we will use to call, the programs that we have written before this. I hope this is clear. So there is no parsing as such going on here. Include db.h. So this is like the final amalgamation. This we are bringing in everything that we have written before. So db, double buffer, syntab, and finally the one that we wrote yesterday, that is lexer.h. Okay, and if you remember, for keywords, we have decided to um, repopulate the symbol table with the keywords. So let us do that. So void, let's just define a function. So syntab create. See, we're using all these now. Syntab create is coming from syntab.h. Definition will be in syntab.c. And then we call syntab insert. And we insert the keywords right now. What is the keyword? We have if, then, and else. So I hope you guys remember what was the syntax for syntax insert function. First one is the sim type. Okay, what is the type? Then second one is the actual lexeme. Else. The third one is the line number in the program, in the input file, but because this is not really part of an input file, we just say 0, line number 0. And then the last one was, I think, the token number, right? Which we have already uh, defined in Lexer, Lexer.h yesterday. If else then line number 0. Oh, yeah, that's all. So assuming we have just 3 keywords, this is how you will be loading the keywords into the symbol table. Okay, now let us define another function, parse. This is like going to represent a parser. It's going to simulate a parser. Please remember that a parser is the one which actually invokes the lexer to generate tokens and provide it to the parser, so that the parser can come up with the syntax tree. I hope this flow is clear. Okay, even though lexical analyzer is the first component in a compiler, it's actually the parser which is basically the second component in a compiler, which always invokes the first component, that is the lexer, to give tokens to it so that it can generate a syntax tree and check the syntax. And of course, what does the lexer do? It will generate tokens and give it to the parser. So that's a flow that we have understood quite well by now. So let's declare a variable integer variable token, and we will be calling yylex. I hope all of you remember yylex is coming from yesterday's program, that is lexer.c. yylex will always return an integer. That integer would contain either the token number, or it would contain something else, like for the error thing. So whatever it returns, we assign it to token. Okay, the variable that we have just defined. So while token whatever is in token is not equal to end of file. I hope all of you remember what is this end of file. This is indicating the end of the input file. Okay. So using that token, we will, because we have mainly three cases rather. One is for identifier. The second one is for numbers. In numbers, we have two possible variations. One is for integer and float. And the fourth one is for keyword. But as we know, keywords, we have already populated ourselves into the symbol table, so we don't really need to take care of that anymore. So this is just trying to print out the attribute, the values of the integer. If the current lexeme is an integer, we would like to see what is the value of that thing. Okay. Now this yyl, I hope you remember, this is from the union. And we had ival and dval for integers and real numbers respectively. So I'm just using, so it would be like if the return lexeme is, which is in token, the token variable, if it's an integer, it's going to print out the integer value. If it's a floating type, it's going to print out the floating value. And what if it's an identifier? Okay, in that case, we will just print out the. See, now you cannot simply print out the identifier, because what is coming in is just an integer. Okay, so you use that integer like 258 or 259, whatever it might be, and then you can simply call the syntax print entry function and print out the information related to the identifier. Default case, nothing. Break. Okay. Now the first thing we need, so finally we have the main function here. The first thing we need is an input file, okay, which will contain the input, obviously. That would be like tokenized by the Lexer. So let's have something like test.txt. We need to create a file, okay, in this working. And then we load the file into the double buffer, okay, using init debug, which we had defined long back in db.c. Pass the file name. And once this is done, you load the keywords. This sequence is important because the keywords need to be loaded first before we start with the lexical analysis. And then you call yyparse. Okay, and as you can see, yyparse will in turn call yylex, which is the main, the most important function in this entire. I mean, we have written 4 C files. Out of all these 4 C files, yylex is by far the most important one. Important in the sense this is where we actually start the lexical analysis. And finally, we call destroy debug. Okay, that's it. Any questions here? By the way, you
No,
can
sir.
print out. Okay, you can print out the token number. Okay, here. Token number would be an integer. So just to check if things are working well or not. So this is it. Right. Now, before we can run the program, if you remember, we need to load a file, right? This one, test.txt. We don't have a file yet. So let us do vi test underscore, no, test.txt. And what do we put here? We put all the possible things like if A is greater than B, then C. Uh, did we have this operator or not? Do you guys have the DFA with you? Did we have this assignment operator or not? I don't remember. Can you please check because I don't have my notes also. In the DFA for relational operator, okay, I think I'll just leave it for now because you guys are not responding. I don't have the DFA actually with me. So anyway, if A is greater than B, then C. Uh, then we can come up with something I want. We're just checking, right? We're just checking the input. 200. What else? 1.2 E10 8. Yeah, that should be enough. We'll save it. And now let us compile the program. Hopefully it works. This is the real deal. Okay. Just writing programs will not help if it doesn't run. So let's hope it runs. So how do we compile so many files? So you can compile, you can link the object files, but let me tell you a easier way of doing this. I mean, both are same, but this is what I usually do. CC and start with the C files, db.c, syntax.c, lexer.c, and parser.c. Oops. So no errors, right? That's a good sign. Next, we need to run it. Okay, something is happening. Token 266, 256, 263, a variable. What was the input actually? If A is greater than B, no? So let me just put that down. Okay, let us just comment this out. It's giving out too much of information. Okay, keyword is missing. Obviously, it's missing because we don't really have a statement inside the switch, inside YY parse. So if the keyword is missing, but that is okay. It's not an error. You just need to add one line and print out the lexeme information. Then A comes as a variable, which is correct. Line number 1, token number 263. Then B also comes variable, line number 1, 263. Then lexeme C comes variable, line number 2, 263. Then dval is what? Okay, I had put 1.2, so that is coming here. Then ival 300, and last dval is 12 point. I had done something 1.2 E10 or something. No, 7, I think I've done that. Okay, so all in all, the program is working fine, right? It's a success. Okay, congratulations to all of you who have been with me throughout this entire programming session. It's not perfect in the sense, I'll leave that as an assignment for you guys. Not really an assignment, as just a programming practice. So we are missing information on if, isn't it? IF. So in this printout, we should see the keywords also with their line number and token number. Line number, of course, doesn't make sense. It would be 0. But if it's token number, whatever was defined in Lexer.h, I think. Yeah, you should see 266, 267, 268, and so on. Right. Yeah, that's all I have for today. Do you have any questions?
No, sir.
Okay, that's good. Others? Okay, so now what you need to do is, all of you who will be watching this video now or later, you have to try out these programs on your own, okay? Until then, I'm not sharing the code, because if I share the code, you will just, you will just run it, which is okay, but that we have already done, right? That I have already done in this live classes. What I want you to do is, I want all of you to type these programs the way we have done and run it. Okay, type it by yourself. Okay, don't wait for someone else to type the program and then you copy it. Or just share the program among yourself and run it. See, running is not a big deal. What is important is you should have a feel of how the program actually feels when you're typing the program, when you're getting errors and so on. So once you're done with that, once you're getting an output, and once you do what I've asked you just now, like we are missing out on things like if, the keywords mainly, okay? And then you should try the input with some errors also, like something which does not fit into the current language description, like mixing up numbers with some random symbols. So you try out everything. Let me know if you guys get stuck anywhere. And once you're done with these programs, of course, I'm expecting that you guys have been typing all along and not waiting till now. I will like to see the lab report being submitted as a, you have to write a lab report. It's part of the curriculum. You have to do that, and you do that only once you get the output. Okay. So all of you, I want you to write the lab report. Attach a printout of your program. Okay, so you do that and submit it by next week. Okay, am I clear?
Yes, sir.
Okay, so yes, Abhishek.
Can you extend it a bit, sir? We have many exams coming up.
Okay, yeah, not a problem. I can extend it. How many days? How many weeks?
Till November 5th, we have exams, sir, for placements and everything.
Right, right. Okay, yeah, absolutely no rush, no rush. But the thing is, I want you guys to do the programming. I hope you're getting this. And
Yes,
the reason I'm asking for lab record is because again, marks are dependent on that. What you can do is, once you have written the program, if you can simply print out the program, I mean that is also fine. Fine by me. I mean I don't want it a handwritten lab record, but I would like all of you to run the program in your own computers. Okay, only then I will, because basically in the screenshot, I'd like to see your name, the name of your system. Okay, make sure somehow, somewhere, your name comes up in the output window. If you are using Windows, I don't know which IDE you can use, but if you have a Mac or if you have a Linux installation, that would be very nice. Okay, so just do that. Make sure you submit it by November 5th is your last. So when do you want? Let's fix a date. Yeah, you guys decide on a date and tell me now. Maybe on 11th November. Will that be okay?
Yes, sir.
Yeah, 11th November, right? So no, so absolutely no hurry, but make sure you do it by 11th November. Okay, no more extension after that. Okay, so we'll stop here for today, and tomorrow we'll take up. Hmm, I need to think what I will be teaching, but tomorrow I think we'll continue with lexical analysis only. But let's see. I think I'll introduce Lex programming. Okay, I think we can do that. Okay, so before I leave, let me just give you a reading assignment. Tonight, please read up regular expressions, regular languages, okay, from theory of computation. Just do some examples, just one or two examples should be enough. Regular expressions, what are the meta characters we use? You know, the star for 0 or more, plus for 1 or more, and so on. We have many other meta characters in regular expressions. Please make sure you understand all of them. It's not too many, maybe just 15 or 20, maybe even less than that. Okay, that will be that will come handy tomorrow when I start with Lex programming. Okay, then I'll leave you guys for now. I'll see you tomorrow. Okay, thank you.